This is section 5-1. We're talking about monomials, and we are on page 222. Okay, so a monomial. A monomial is an expression that is a number, a variable, or the product of a number and one or more variables. So that's like x, or 3r, or just the number 6. Those are all monomials. What a monomial cannot be is something that has a variable in the denominator, such as 1 over x, or variables with exponents that are negative, like r to the negative third power, or variables under radicals, that's like the square root of 3x. Those are all not monomials. Okay, there's a couple of vocabulary words. A constant. A constant it's a monomial with no variable. So a constant is like 4 or 1/3 or 6. Now a coefficient is different because a coefficient is the number in front of a variable, like 3r. So the 3 is the coefficient, or 1/2 x. 1/2 is the coefficient. Now the degree. The degree is actually the exponents of the variables in a monomial added together, and that'll tell you the degree, like 12 g to the third power h to the fourth power. So then what we do is we add up those powers of our variables. So we have 3 plus 4, because we have g to the third power and h to the fourth power. So the degree of this monomial is 7, because 3 plus 4 is 7. So the last thing we're going to talk about is a power in terms of a monomial. So we get a power refers to the exponent itself, but it's written in a monomial in the form x to the n, where n is the power. So we can say something like 3 to the fourth power, where the exponent 4 is our power, and it tells us how many times to multiply our base together. Okay, so the next thing we're going to talk about are negative exponents. So we looked at positive. Now a negative exponent is something like x to the negative third power. What does that negative mean? That negative actually means you look at it in terms of the multiplicative inverse. And if you remember, the multiplicative inverse is where you flop the numerator and the denominator. The denominator becomes the numerator, numerator becomes the denominator. So x to the negative third power, which we can write it as x to the negative third over 1 as a fraction, and then we flip it and do the multiplicative inverse. So x to the negative third power is the same thing as 1 over x cubed. So you get rid of that negative sign when you flip it. And if it asks you to simplify your expression, you cannot have a negative exponent. Okay, now let's look at another one. So we have x to the negative third power, you get a 1 over x cubed. Now what happens if that negative 3 is in your denominator? So if you have something like 1 over b to the negative fourth power, well, you do the same thing. Your denominator becomes your numerator. It tells you to do the same thing, and you just flip them. So b to the negative fourth power is the same thing as b to the fourth power, or b over 1. b to the fourth power over 1, which you can just write as b to the fourth power. So that is a negative exponent. Next, let's talk about a product of power. So a product of a power, when you have two or more numbers being multiplied, or monomials being multiplied together, if the bases are the same, you add your exponent. So if you have b to the fourth power, b is your base, and 4 is your power. So if you have b to the fourth power times b to the sixth power, you use your base, one instance of your base, b, and then you add your exponent, so 4 plus 6. So now you have b raised to the 4 plus 6, which is b to the 10th. Because if you were to write this out long, you'd have b times b times b times b as your first term, times b times b times b times b times b times b. So, and then when you multiply all those b's together, b times 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 b, there's 10 of them, so that becomes b to the 10th power. So that's why you can add your exponents if you have the same base. Okay, so now let's look at quotient of powers, so division. So if you have division 5 to the 3rd power divided by 5 to the 2nd power, in a product we add our exponents, and in quotient of powers we subtract them if you have the same base. So in this case our base is 5. So we have 5 raised to the 3 minus 2, which is 5 to the 1st power, or just 5. You could also write it as a fraction. So if you have x to the 10th power over x to the 4th power, again you just subtract your exponents and you get x to the 10 minus 4, or x to the 6th power. Okay, another example. What if our numerator, or our first number, is larger than our second, or smaller than our second? So if we have r to the 10th over r to the 12th. Now we have r raised to the 10 minus 12, which equals r to the negative 2nd power. And we know if it's raised to a negative power, you have to do the multiplicative inverse because you can't leave it as a negative exponent. So then you get 1 over r squared would be your answer. Okay. Now let's look at properties of power. The first one we're going to talk about is the power of a power. Okay. What does this mean? So you have power of a power. So you're raising a power to a power. For an example, we have open parentheses, a to the 2nd, closed, raised to the 3rd power. So you're raising this a squared to the 3rd power, which is the same thing as a squared times a squared times a squared. And when you're multiplying a monomial with an exponent with the same base, you add them. So you have a squared times a squared times a squared, which is the same thing as a raised to the 2 plus 2 plus 2, which is a to the 6th. But you can also do this by multiplying your exponents together. So you have a raised to the 2nd power times 3. So that's a raised to the 2 times 3, which is a to the 6th. Same thing. Or if you have x raised to the 4th power raised to the 6th power, the same thing as x to the 24th power. Okay, so now let's look at the power of a product. This one's a little different. The power of a product. So inside of parentheses, let's say you have open paren, x, r, close paren, raised to the 2nd power. So you have to distribute the 2nd power to everything inside your parentheses. So x times r raised to the 2nd power is the same thing as x squared, r squared. You have to give that 2nd power to everything inside of the parentheses. Okay, now let's look at power of a quotient. Power of a quotient. So this time we have open parentheses, x over y, close parentheses, raised to the 3rd power. Same kind of idea. You need to distribute that 3rd power to everything inside of the parentheses. So you get, as a numerator, x to the 3rd power over y to the third power, because you distribute it the whole way through. Okay, now let's talk about if you have a negative exponent. So power of a negative exponent. So power of a negative exponent. In a quotient. So power of a quotient with a negative exponent. So x raised to the negative power. So let's do the same thing. So we have open parentheses, x over y, close parentheses, raised to the negative third power. Again, you have to do the same thing. Distribute that negative 3 power to each part of your quotient, numerator and denominator. So then you get x to the negative third power over y to the negative third power. And you can't leave it like this. So you have to basically do the multiplicative inverse of both your numerator and your denominator, which flips both of them. So then you get y cubed over x cubed. Now let's look at some examples. So what I have is an example that we need to simplify. So I have open parentheses a to the third power close raised to the sixth. So this is a power of a power, which means we multiply our exponents together. So we get a raised to the 18th power. That's all we need to do. Okay, so now what if we have open parentheses negative 2 p to the third s to the second, close parentheses, raised to the fifth power. Okay, so that means we need to distribute that fifth power to everything inside the parentheses. So first we have negative 2 raised to the fifth power times p to the third power raised to the fifth power times 5 to the s to the second power raised to the fifth power. And then we need to simplify it. So now we have negative 2 raised to the fifth power, which is negative 32. And we have a power to a power, p to the third, raised to the fifth power, which gives us p to the 15th. And last, we have 5 to the second power, or s to the second power, raised to the fifth power, which is s to the 10th. And that's all we need to do. Okay, so the last example that I want to do in this is open parentheses. The fraction a over 4, close parentheses, draw that a little bit better, raised to the negative third. Okay, first things first is we have a negative. So we're going to have to flip this guy. So we can do it one of two ways. Distribute this power of negative 3 first and then flip it, or flip it first. But we're going to distribute first. So you get a to the negative third over 4 to the negative third. Now we have a negative on both of those, so we flip them over. So we get 4 to the third power over a to the third power. On our numerator, we have 4 raised to the third power, so we need to evaluate that. And 4 to the third power is 64. So our final solution is 64 as our numerator over a cubed. All right. Okay, so then the last thing I want to look at is a little trickier. It's like using multiple, we can use multiple properties to simplify an expression. Okay, so here we go. So what we have is open parentheses. Our numerator is negative 2x raised to the 3n all over x raised to the 2n y cubed and fraction, close parentheses, all of this is raised to the fourth power. So the first thing we need to do is there's two different ways. We can simplify our fraction and then raise it to a power, or we can raise everything to a power and simplify our fraction afterwards. I think we're going to start by simplifying our fraction first. So let's look at this piece by piece. Okay, so we have a coefficient of -2, and if we look at our denominator, there's no other coefficients down there other than 1, so we leave it as is. And now let's look at our x's. We have a base of x, and on the numerator is raised to the 3n, and the denominator is raised to the 2n. So we can subtract those. So what we get is open parentheses, open fraction, -2 x raised to the 3n minus 2n, because you subtract your exponents with the same base, all of that over y cubed, close fraction, close parentheses, raised to the 4th. Okay, now let's go ahead and simplify our numerator. So now we have -2x raised to the 3n minus 2n. And when we subtract those, we get just n. So our numerator becomes -2x raised to the n, because 3n minus 2n gives us just n, over y cubed. Close fraction, close parentheses, raised to the 4th power. And now we've simplified that, so we can go ahead and distribute this 4th power. And remember, we have to distribute the 4th power to everything inside the parentheses. So we get -2 raised to the 4th power times x to the n raised to the 4th power all over y to the 3rd power raised to the 4th power. So let's simplify. -2 raised to the 4th power is 16. So our numerator is now 16. X to the n raised to the 4th gives us x to the 4n all over, we have y to the 3rd raised to the 4th power, so we get y raised to the 12th power. And that is our answer.